Hello, everybody. Hello, Philippines in the world. Hello, all parts of the world. Okay, welcome back to my white channel. This is again, I am a senior voice, my chemical engineering diary. So, I am going to discuss still under the subject of physical chemistry. Okay, so we haven't yet going to deep by Hackett on Sager theory because I need to finish this chemical reaction kinetics basic concepts and basic principles or basic foundation. Okay, something like that. That will be done later, the deep by Hackett on Sager theory. But before that, I must finish this chemical reaction kinetics or under chemical reaction engineering. Okay, something like that. So yesterday, uh, I discussed about reaction mechanism. Okay, the rate, load, the overall reaction order. Okay, how can we determine if it is an intermediate, a catalyst, and then how can we have chemical reaction steps or reaction step one, two, three, or elementary reaction steps, something like that. And we need to add those elementary reaction steps, and we can have now our overall reaction in the end. And then we will determine the overall rate, overall reaction rate, something like that. Okay, this topic is still related to yesterday. I'm going to, have additional information for other topics like this. Okay, but there's also a link. But this will be having intensification, or shall we say additional, right? Okay, so these are our learning outcomes. Okay, we have 7 learning outcomes. Number 1, we need to understand what is a rate law. Okay, rate law is a small r. Okay, rate law is a small r, or you can have also an big r, it depends on you, as long as it is a rate law. A rate law is also known as reaction rate. Okay, reaction rate or chemical reaction rate. So if the problem will say, what is the reaction rate? Automatically, you are pushed to find the rate law or chemical reaction rate. It's just the same. Okay, it can use. Number 2, the rate law, guys, are basic. Only we need to discuss only the zero order, first order, and second order. We need to touch third order, but we don't go beyond specific formulas for that. Okay? And then number 2, we have the integrated rate law. Okay? This comes from the rate law. And then we need to integrate this to come up with another formulas and equations. Okay? So number 3, we have the half-life. The same as the theory in the nuclear chemistry, the theory of decaying, okay, or disintegration of metals and elements after how many years, what is the half-life, something like that, okay. But here, it's more on intensification, or shall we say, there's an additional, okay. Number 4, we have the reaction order, and it's in here, we need to discuss each reaction order with respect to each reactant. Okay, and also the reaction order overall, in the overall chemical reaction. Because sometimes the problem will ask, what is the reaction order with respect to this reactant? Okay, for example, if I have hydrogen gas plus oxygen gas will produce water. Sometimes the question will say, what is the reaction order with respect to oxygen? What is the reaction order with respect to oxygen? Okay, and what is the overall reaction order? So you have to add each reaction order, oxygen and hydrogen. Okay, something like that. Number four, yes, N is the reaction order. Do not be confused with small letter n as the number of moles that we keep on using in solving in chemical calculations on stoichiometry relationship problem solving. Okay, here also small letter n, but specifically on chemical reaction engineering or chemical kinetics. Okay, like that. The main purpose of this topic really, guys, I kept on repeating, okay, is really to determine if our chemical reaction is fast or slow. Okay, how fast or how slow our chemical reaction really is. If we need to add a catalyst, okay, we need to add an inhibitor, we increase the temperature like that. So we increase the concentration. So what will happen to our reactants or our initial rates or our products, something like that. It's gonna be the purpose for this specific topic, chemical reaction kinetics. Okay. And number five, relationships between the half-life, between the rate constant, okay, the rate law, and the initial concentration represented as AO. Okay, like that. Because we have also final concentration represented as A. Okay, and then you have the graphs. The graphs to illustrate and to understand the behavior of each quantity. If it will rise, it will fall, it will be decreased, it will be increased. Well, our graph produce a curve facing upward. Will our graph produce a curve facing downward or slanting, okay, or erratic, or shall we say straight line pointing downward, diagonal, or straight line pointing upward, diagonal, something like that, or it could be a zigzag representation of a graph. It depends when you plot certain quantities. For example, you plot concentration versus time, something like that, okay, the rate reaction constant versus the time, something like that, okay, but in most cases, this will be concentration versus the time and also the rate constant versus the time. But we can still have also the graph regarding activation energy versus the rate constant. Okay, we should not forget that also, because through the graph of activation energy and time, we can have a chemical reaction to proceed because we have activation energy. As I told over and over again, we don't have chemical reaction if we don't have activation energy. Okay, so I already discussed this last 2 days ago, right, regarding the Arrhenius theory. Okay, employing the Arrhenius equation, determination, and describing the relationship between the reaction rate constant, okay, and the temperature of many chemical reactions and physical reactions, something like that. Okay, but mostly chemical reactions. Okay, what we are referring here. Okay, number seven, hypothetical reactions. What do you mean by hypothetical reactions? These are reactions, guys, that is only a representation. For example, A plus B is equals to C. Okay, 2A plus B is equals to C. Okay, A plus B plus C plus D is equals to F. A plus B is equals to D plus F. So these letters could be represented are real elements and compounds later. The main purpose only is to understand what is or what are the mechanics in predicting a product or in identifying a chemical reaction, producing a product to familiarize, because we need to familiarize the mechanics or the methods of how to obtain the rate law, the chemical reaction rate or the reaction rate, okay, with respect to the initial concentrations. Because here, guys, in chemical reaction kinetics, we are focusing in the initial concentrations. Okay, that's why we have initial rates determination. So usually, initial rate determination is undergoing a series of laboratory tests. Okay, result one, result two, result three. And through that results, we need to have a comparative study between the initial concentration to the final concentration in the reactant, not in the product. Because if we mean reactant, there is also an initial concentration of that reactant and then final concentration of that reactant. It doesn't mean the final concentration is the product. Okay, like that. And then we need to correlate or establish the relationship with rate constant. Then we can solve for the concentrations of each elements in the reactants or in the products, as long as you have the stoichiometric relationships. Okay, it's easy to solve because we need to balance. We need to identify the number of moles also before anything else. Okay, it's automatic because this is always in chemistry. That's the first step to balance the chemical equation. Okay, but that is not our focus, but understood na siya when we have a chemical reaction. Okay, because something wrong with your concentrations and then it will become wrong in the end if your number of moles are wrong. Moles mean the coefficient of each element and compound. Okay, again, atoms is the coefficient times the subscript. Okay, I keep on stressing this one because mole is not an atom. Okay, mole is can be an abbreviation of a molecule. Okay, that's related. Okay, when I say 1 mole of water, okay, that could also equivalent as 1 molecule of water. Okay, because mole and molecule can be applied in a compound, but it can never applied in single element. You will be grammatically incorrect if you say 1 mole of oxygen, something like that. Okay, so you have to take note the molecular structure, something like that. Okay, 1 molecule of sucrose. Ganon. What's sucrose? Carbon 12H22O11, the white sugar we have. Okay, so number 8, problems. Last will be the problem solving, okay? It's very clear. This is our learning outcomes. Okay, for this vlogging and live stream. You know, guys, I keep on the vlogging and then I keep on improving, right? Because before I don't have this. I don't have the learning outcomes because it's very good to have an objective of your discussion to point out, to give you knowledge and information in this our goal at the end of the discussion, something like that. But I forgot to highlight that in my previous live streamings, okay? Because I'm not really an educator, okay? I don't have education units. Okay, so this is an informal way of teaching. Okay, and now I discovered as I keep on reading, and I also connect that with my previous trainings also in occupational safety and health. Usually we have the learning outcomes, okay, or the objective. So I apply that here, okay, something like that, okay. So let's go now for the first one, the rate law. Okay, now for the rate law, we start for the very basic, okay. Rate law, reaction rate, or chemical reaction rate. Guys, if we speak about the rate, there always time in the denominator. So what is our unit for a rate law? Rate law. Okay? As I told you, if you put law, that is already a final equation. Okay, final equation of the scientific discovery or the scientific research. So you don't have a scientific law if you don't have a scientific research. Okay, something like that. So this is a rate law, for example. So if there's a law, there's already have formulas and equations. After the theories established by those scientists. In here, Arrhenius is the popular scientist for this specific topic in chemical reaction kinetics. Okay. Rate laws, one letter R. Okay. Or you can have it, guys, as a big R if you want to. It depends on you. That's only a representation. Okay. Small r, rate law. For example, if I have a reaction a reactant capital A will produce a product capital B. Okay. This is only hypothetical, okay, meaning to say this will be replaced with a real element or a real compound in actual experimentation or in the problem solving. This only to understand fast or for easy understanding. So A will produce B, okay? So what is our rate of chemical reaction, rate law, and the reaction rate? So the R is equal to, okay, small letter K, okay, times close and open parenthesis concentration of capital A, like that, raised to the power X, or raised to the power N, it doesn't matter, okay, because hypothetical again. But in most practice, N will be raised to this, but X is just okay. Okay, this X is the reaction order with respect to A. Okay, so it's gonna be like that. And then, okay, if I will put number of moles beside capital A, I said 2A is equal to B2. Okay. Again, hypothetical because our concern is not on the product. So 2A is equals to B2. Okay, so our rate law will be, or rate of chemical reaction, R is equals to rate reaction constant, okay, small k, times A, concentration of A, raised to the power 2, something like that. Okay, so our reaction order N or X is equals to 2 with respect to A. This is in case wherein we have only one reactant to produce the product. Okay, something like that. This is the rate law. Okay, something like that. Now, we have the different orders, right? We have the N is equals to 0. Okay. N, we denote N as reaction order na lang siya in order we will not be confused. Okay, reaction order. Okay. Okay, guys. Okay, like this. So we still use this very basic equation. A is equal to B to attain and to obtain a rate law. Okay, we will not go on the chuba chuchu by molecular chemical reaction, tri-molecular chemical reaction, of thermomolecular reaction. Okay, something like that. So our rate law will start from the basic A reactant will produce B. So in this equation, if we remember the types of chemical reaction in our general chemistry, okay, we have the general chemistry lecture in first year college, something like that. So this is usually a decomposition reaction wherein one compound will produce several elements somewhere along in the chemical reaction. One compound will produce several elements, okay, because the bonds, chemical bonds will be break down, okay, like that. So because of activation energy, okay, something like that. If there's no activation energy, then there will be no breakup of molecules to produce the products, something like that, okay? So N is equals to 0, meaning 0 reaction order, okay? N is equals to 0, so 0 reaction order, okay? Like that, okay? Now, since 0 reaction order, looking back to the main equation, the very basic equation A is equals to B, okay, like that. So our rate law for the 0 order reaction, okay, analyze first. So this is gonna be R is equal to K times capital A raised to the power 0, right? Because N exponent will be our reaction order. So something that's I will put down here. So R is equal to K times A raised to the power N. So therefore, R is equal to K A raised to the power 0. Hi. Thank you so much. Yes, thank you so much because this is quality live streaming with academic information. This is not just comedy or whatever. Or this is really academic information for students in taking up college of engineering, something like that. Okay, so that's why so many people will not watch this because if you try to watch this, our brain cells will keep on working. Okay, so nobody loves to always think because it will cause a headache, something like that, or stress. Because mental ability usually causes mental stress, and we don't want that. Most of the humanity in the whole world, they just love to watch through eyes, enjoying the eyes, but sometimes they don't want to exercise the mental ability and brain cells. So this type of vlogging and streaming is more about exercising the mental ability, okay? Or we need to energize our brain cells for this academic information. But most of the people all over the world love only to look or visualize, videos like sports, okay, news, shootings, politics, because these topics don't need really to push us to think. This does not require critical thinking. All you have to do is to watch, to hear, to listen. But it doesn't push you to think, okay, to analyze, to comprehend mathematically or analytically. But this kind of vlogging and live streaming is very highly technical and academic in effect. That's why it looks like boring to the majority. Okay, something unless you are taking up engineering course in your first year college, second year college, or you're studying college, or you are taking up courses that involves sciences because it's related to science really. Okay, something like that. Get the point? And then that's why. And this kind of live streaming also manage when this is really, not scripted. I don't want to vlog and to live stream scripted at all. Okay, since I am a chemical engineer, I want to exercise my brain cells. Okay, and try to remember the academic stock knowledge and then only having a little of review like that, reading, research. But as you can watch on my presentation of my discussion, I don't really I don't do the scripted flagging on the spot really. Okay, that's why in my problem solving, somewhere along the way, I will become a little bit error or wrong. Sometimes I will repeat it again and going back again, like this. And then this is gonna be my format or way of live streaming. Okay, method. That's my method. Okay, due to the fact also because I am working 8 hours. Okay, so I don't have really time, full time to prepare. Okay, script or whatever visual aid so that it looks like perfect, organized, systematized, and to eliminate the jargon, redundancies, duplication of thoughts. Meaning to say, this is not really polished, okay, only spontaneous. What comes on my brain cells, I will talk directly as long as I have the guidelines here. Okay, something like that. Okay, because these topics really are already discussed in my college days. All I have to do is to refresh, and some are already accumulated in my brain cells. I have to, discuss it to you, something like that. Okay, like that. Okay, sorry talaga that my number of views are not very high. For me kasi, it doesn't matter, okay, because I'm enjoying the most, okay, with regardless of viewers, because this is only my secondary, approach, because I am working, okay, and I don't depend for this, okay. The revenues and income that I will be obtained from my YT channel, I don't depend for this, okay. Something like I'm just enjoying because I love really to share academic information to anybody else, especially college engineering students, something like that, okay. It's very good. Now going back to business, but of course I am very, very thankful to those who watch my YT videos and live streamings, because really honestly, day by day my revenues are increasing. Okay, I don't have to state that to you. What are the revenues? But it's really increasing every day. Okay, like that. And then my style is I don't really want to withdraw my revenue every month. Okay, I'll just accumulate that in my in my bank account. For the main reason also, that's not too big, but it keeps on rising. Okay, like that. And I found out, guys, that it's not really the number of views, as long as you have a lot of videos. Okay, because once the viewers will just click, even if 1 second, it will score to your to your video, and the like, it will score also, the comment, it will score also. Not necessarily they will watch for a longer period of time in your entire video. So that's why every day I kept on having vloggings and live streamings, because I discovered that my revenues are kept on increasing every day. Okay, so I fight. I increase through creating more videos rather than convincing more viewers. Okay, because we cannot force anybody else to like our videos, right? They have the full freedom to reject our videos, to delete our videos, because for the reason we have different perspective in life, and there's a conflict of interest. Any individual has different, different likes, dislikes, or personalities, attitudes, and character. Some like sports, and some don't like sports. Some like politics and only eating, going to the beach. They don't love also to talk about investment. Okay, in the entire humanity all over the world, we don't have the same perspective in life. The fact that all those guys or majority of them will watch your videos. Okay, but the trending videos really is due to sharing platform. Sharing. If this guy will share, he will share also to another people, and then this people, it will multiply if so many will share. Okay, but it is not also an assurance that if they share that video, all will watch. As I told you earlier, it will become a million views. For example, if you will just watch for 1 second, 2 seconds, 3 seconds, it doesn't mean you have to watch that all throughout. The counting is per head, okay, per head, per click, something like that. If you just watch 1 second, then score already the views. Okay, if you see in the YT channel that have 3 million views, 4 million views, those million views not necessarily they finish the video in the total duration of the watching of that person. No, it's not. Even if 1 second only, and then you escape. Okay, that's score also for the 2 million. Okay, you are part of that 2 million already. Okay, so it's not like that you have to finish in order that you will be scored all the numbers. It's not. Okay, so like that. So for the ads, it will be okay because the ads are going in the middle, going in the last. So if my style, I put my ads because we will be the one to put the ads. If you are a monetized YouTube content creator or social media influencer, or shall we say YouTuber, me, I am a small YouTuber, okay? And I'm not a popular YouTube content creator. I'm just an ordinary YouTube creator, just like anybody else all over the world. Okay, something like that. Okay, So in me, I don't have to worry regarding the views because I love doing this. Okay. And part also of the reason is that I don't want to become stagnant. Okay. Stagnant, meaning my learning will just fade. Okay. I want my learning to be intensified, enhanced, and will be more, and more, something like that. Okay. So because we don't know really in the future what's gonna be happening to us. Okay, something after 5 years, after 10 years, after 8 years, something like that. Okay, then you can migrate to another country, for example, Canada, Australia, or Europe. Then you can use also your knowledge there, not only your. Okay, you should be, what I missed. Help me about this one. You should be versatile. Versatile, meaning not only focusing to one line of specialization. Okay. In my case, I am on the occupational safety and health. But if you talk about also chemical engineering, chemistry, and sciences, I can also have knowledge for that. Okay, because that's my profession. Okay, so you need to be balanced, just the chemical equation. You need to balance the chemical equation so that you can solve what is being required in the problem, something like that. Okay? Ganun naman talaga ang life, you need to be balanced, right? Okay? Mentally, spiritually, morally, physically. So the whole picture, you should be balanced or else you will be, what will happen to you if you're not balanced. Okay? Something like that. Just like chemical reaction. Okay, balance chemical reaction or balance lifestyle. Thank you so much. Oh, Mami Shuen. Mami Shuen spoke to me. You deserve more views. Thank you so much. She's telling me like that now. Thank you for that. I'm very, very grateful. Okay, going to the rate low. So, guys, this one. R is equals to the concentration of A raised to the power n, and n is the reaction order. Then n is equals to 0, and then substitute. Then, guys, in differential calculus, I think so, the rule will be any constant raised to the power 0 or any number, whole number, or variable, or anything chuba raised to the power 0, it will be equal to 1. In this case, rate low is equals to K. That's why, guys, in a problem solving, some reaction rate are presented the same unit as the rate low. Automatically, that is a zero order chemical reaction. Okay? And you wonder why like this? It's just the same unit, something blah 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 chu. Okay, because that is a zero order. Okay, I will explain why. Okay, R is equal to K times 1, or R is equals to K, like this. And now, if you are taking up Bachelor of Science in Chemical Engineering, so this is very important also in the theory. Okay, so for example, what particular order of reaction in which the concentration is independent to the rate constant? A, zero order; B, first order; C, second order; D, third order; E, none of the above. So what is your answer? Since you have already this concept, I told you in the zero order, so the answer will be zero order, because in zero order, guys, that is independent to the initial concentration or the concentration. Okay? It will never be affected to the concentration. That's why in your problems related to zero order, it doesn't presented with concentration. Usually the table only have rate constant and the half-life and the K, or the rate low, but there is no concentration. Maybe if we put the concentration, it will just confuse the students. It is not relevant on the problem, because sometimes also problem solvings, the questioner will have data that is or are not used. Just the purpose only is to confuse the students and examinees, or it is related but not really being used in the equation. Just the purpose of to analyze further. Okay, at this temperature, at this pressure, but actually it will not be used in your equation. Okay, just like an STP, right? In the gases, ideal gas law and ideal gas law, sometimes it will say at standard temperature and pressure, temperature is equals to zero and a pressure of an atmosphere. So you don't have to substitute that all the time, the 1 atmosphere and zero pressure. It will just state that that gas will behave ideally. Okay, something like that. Not necessarily that you have to substitute that in the equation. A lot of equations there. I think there are 14 equations in ideal gas law, right? So you choose among them. Okay, like that. Okay, so that's the point. Okay, so R is just equal to this. So therefore, guys, our unit for rate law is capital M per second. So this is also our unit of K in the zero order. Okay, like that. Moles per second. The same, huh? I will encircle this one. This is for N is equals to zero. Okay, K and R, or rate of chemical reaction, have the same unit, molarity times second. The capital M stands for molarity. Okay, molarity, this is an expression measuring of the concentration expression. Molarity, capital M, the same as molarity. Molarity, moles of solute per kilogram of solvent. Okay, and then the normality also. Okay, equivalent weight of solute over liters of solution. Okay, something like that. That's why you need to compute the gram equivalent of solute for that. Okay, but it undergoes ionization, okay, in the certain reaction, and then the replaceable H and replaceable OH will be your denominator, and the molecular weight divided by to those either replaceable OH or replaceable H, and that is your equivalent weight, something like that. So molecular weight is very important in normality. Capital N naman siya. Okay, these are all expression of concentration. The normality, the molarity, the molality. The molality is symbol small letter n. The normality, capital N. The molarity is capital M. That's why here, capital N moles per second. This is molarity. Okay? In chemical reaction kinetics, common unit is molarity per second. Or this is generally concentration over time. Okay? Because rate always have time in the denominator. So concentration over time, the unit of concentration is molarity, and the unit of time is in second. So it could also be in minute, in mass, any type of period you want, that's still also period, not limited to seconds only. But most of the problem solving expressed in second in the denominator and concentration in the numerator, something like that. And take molarity, normality, molality are all solubility. Okay, the measuring of the expression of the concentration having solute and solvent in a particular solution. Could it be an ionic solution, electrolyte solution, inorganic solution, organic solution, aqueous solution, something like a lot of solution, tuba, chuchu. Okay? But your main idea will be solute and solvent. Review. If more solvent, that is a diluted solution. If more solute, that is concentrated solution. Okay, that's why we have a concentrated juice, meaning to say there's a lot of solute there, meaning the extract, the solid substance rather than the liquid or the juice. Okay, the juice is the solvent, right? So meaning they put a lot of solute. Concentrated, okay, something like that, so that we can understand. That's why chemistry lecture, if you don't pass that one, you cannot take physical chemistry, physics, thermodynamics, like this, qualitative chemistry, quantitative chemistry, organic chemistry, biochemical engineering, biochemistry, and then unit processes. The highlight is there is the chemical reaction engineering. Okay, and you cannot also take the industrial process control in chemical engineering, and most of all, you cannot take unit operations. Okay, unit operations 1, 2, and 3. Unit operation class is just a general term, but this unit 1 composed of so many topics in there. Unit 2 composed of so many topics in there. Unit 3 composed of so many topics in there. But these are all physical and chemical separation processes. Okay? Physical and chemical separation processes. Okay? For example, distillation. That is a physical activity. Okay? Distillation. And then if you said crystallization, that could be still physical, right? You didn't add any catalyst for that. Okay, something like that. Drying also is a physical separation. Okay, but for adding temperature, pyrolysis, thermal catalytic cracking in petroleum industry. So that is already chemical separation processes. Okay, separating the liquid to vapor mixture. Okay, something like that. So that's why it is called physical and chemical separation processes. Okay, like that. Heat transfer, momentum transfer, mass transfer is under physical and chemical separation process. Meaning, physical and chemical separation processes are general, are broad. Okay, that is under in unit operations. Okay, the operations here meaning it could either be physical, it could be either chemical. Okay, right? When you do an operation, it could be either physical or chemical. Two only. Or it could be either artificial or natural. So the natural is the physical. The artificial is the chemical. Okay? Because you alter the phase of matter, the solid, liquid, and the gas. You alter, meaning you apply heat, you apply combustion, you apply internal energy, okay, something like that. Okay? Guys, osmosis is not a chemical reaction, it's still physical separation process. Osmosis, reverse osmosis. Okay, because the water will just pass on the the filter in a semi-permeable membrane. Okay, for example, the seawater. Seawater, you want that to become pure. So the process will be desalination, removing salts from the seawater. And the specific process is known as reverse osmosis, something like that. Okay? But the seawater will pass on the semi-permeable membrane filter. Okay? You are only allowing that to happen by physical separation means, not chemical. Okay? There's no adding of catalyst. Okay? There's no heating to change that to vapor. Okay? So the chemical changes is more on changing the state. Okay? But the water is still water in reverse osmosis. Okay? You get the water from the sea, and then the product is still water. It doesn't change to gas or solid. Okay, this is physical separation process only. Okay? So put that in your brain cells. If it is a chemical separation process, the phase of matter will alter. Okay, from solid to liquid, liquid to solid to liquid. But for physical only, it will liquid product, solid product. But it involves a lot of physical operations only somewhere along the way. For example, you will only mix something like that. These two liquids. Okay, that's still physical, right? Okay, like that. So you need to understand also the physical and chemical changes because that is chemistry all about. Okay, the study of chemical and physical changes. Okay, and how they behave in a certain phases of matters. So we live within it. Okay, muna na siya ha, our ray. Okay, formula. Okay, this is the zero order. Okay. R is just equal to K. Okay, bingo na. Now we go to the N is equals to 1, which is the first order. Okay, like this. Okay, still using the general formula. A is equals to B. Okay, like that, guys. Ay, nako. Ang hirap kumita ng pera. Like this. But because honestly, I'm paid by YouTube, right? So, N is equals to 1. Reaction order equal to 1. Meaning to say, overall reaction order because this is A will just produce B. Okay, so R is equals to K times a concentration raised to the power n or 1. This one. Notice. Okay, so this will become R K times A only. Okay, R K times A. Guys, in this n is equals to 1 or first order overall reaction order, okay, like that. So this is dependent to the initial concentration or the final concentration. Meaning to say, if you encounter problem solvings in the future examination, science examination usually, right? So science examination meaning it's mixing physics, mixing earth science, mixing geology, biology, chemistry. So that's science examination. If you experienced that before, I experienced that before when I was in high school. I compete for science quiz bowl. Okay, in University of San Carlos, Talamban. So the science question really is mixture. Okay, mixture, not really on chemistry. Have physics, biology, geology, earth science, astronomy, okay, like that. What else? The planetary science also it's included, something like that. So a lot all about sciences, okay, but I never won. Okay, I never won because that's entire Cebu from south to north. Okay, it doesn't mean that I'm not good, but there's a lot of competitors. Okay, something like that. Okay, so maximize your potential because I love really science. Okay, science and English are my favorite subjects. Okay, English. Okay, going back to this, rate low is equal to rate constant times the initial concentration. Okay, this one. Okay, like that. So dependent on the initial concentration. Okay, so in this equation class, R is equals to K times A, you can determine the proportionality relationship. So Sotero, what is a proportionality relationship? That could either be directly proportional and inversely proportional. The inversely proportional is in the denominator and the quantity you're asking for. Okay, the directly proportional will be in the numerator versus the quantity you are asking for. Okay, for example, it's R is equals to Ka. So I will obtain the value of K with constant. So K is equal to R over A. Okay, as I told earlier in verbal statement, okay, in the denominator is the concentration A. So the rate constant will increase, the concentration will decrease because that is inversely proportional. And then if the rate constant will increase, the rate law or the chemical reaction rate will also increase. Now, this will help a lot somewhere in your solution or solving the answer for what is being required in that particular problem, because you have an idea what's gonna be happening in your concentration after this, adding this sodium chloride plus water, and then what will happen to chlorine or chloride in the end, like this. Okay, yeah, if you don't know the relationships, then you are just solving without understanding what's gonna be happening somewhere along the way. Okay, just to get the answer only, your purpose, but you don't know what's really happening, the behavior of those liquids and gases when you do that particular operation or processes. Because that's the main important really. Okay, that's not really the numbers. That's the really important. You should understand why. This problem solving is a tool only to help us understand. Okay, the theory, but this is not the center really how to solve, okay? Because these things are not being asked in the real world. We are working. For example, you're a process engineer. You are not asked, what is the volume of this like this, and then compute for no, and I will do the interpolation. There's no such like that in the real world. All you have to do is to analyze what's going to be the effect after this. If you increase the temperature, if you lower the temperature, could I produce a very cooked product, cooked meaning naluto yun siya pag-ayo, or sakto ra ba siya, hilaw ra ba siya, something like that. If your product also involves a lot of thermal processes, or especially pyrolysis, heating of the, shall we say, raw material, okay, to a certain temperature. Or you could add catalyst, something like that, to speed up your rate of reaction somewhere along the way. Okay? Ganun talaga siya. Okay? Understand the relationship. This is reaction order, first order. Okay? N is equals to 1. Okay. Now, second order, N is equals to 2. Okay? Second order, like this. See, in second order, let's revise a little bit. We will not use this A. Actually, we can still use this one if you want. Okay, but let's have another, let's say 2A plus B. Or you want that one, or just stick with this? Let's just stick to this standard, ha? Later na lang, kasi po, we don't employ coefficient muna, okay? Is equals to, so still using this A equal to B, okay? So R is equal to K times the initial concentration of A raised to the power n 2, okay? So this is 2, like this. Okay, this one. This is our second order. Okay? Raised to the power 2, because that's 2 second order. So guys, what is our unit for R for this in the second order? By the way, we need to know the units of R in the first order. Of course, all are molar per second. The unit of K, okay? Because the concentration, very easy. Okay, because molar per second. Okay, moles per liter. Sorry, moles per liter. Okay, or it could be molal. Okay, molality, right? Mole per kilogram of solvent. Or it could be normality. That's also a concentration. It depends on the situation. Okay, but in here, focus on the molarity, ha? Okay, like that. So in here, first order, our unit is, let's just substitute the individual unit, ha? Okay, R is equal to m per second. Okay. Before going to sorry, as I told you, not organized, right? Okay, because not scripted. R, okay, like this. So R in first order. So R is equal to m molarity per second. Okay. Have K times the concentration. The concentration expressed in moles per liter. Okay, concentration moles per liter. Okay, like this. Moles per liter. Okay, like that. So your K will be molar per second divided by moles per liter. Okay. So your unit of K for the first order will be what? I ask you. So let's do the cancellation. It will take a longer time, but just wait. Okay. So molar is moles per liter, right? Agree or not? Molar. Molar is the abbreviation of molarity. Molality, the abbreviation is molar. The abbreviation of molecule, mole. But atom, sorry, joke lang. Okay? May mga abbreviation talaga. Okay? Something like that. Okay? So, molarity. So, K, solve for the value of K. In algebra, K is equals to molarity over second over mole per liter. Okay, let's put the molar per second in the numerator. What will happen? Okay? And then mole per liter. Okay, so K, reaction constant or chemical reaction constant is equals to molar or molarity of moles per liter. Okay, moles per letter. Then per second pa siya. And then moles per letter. Okay? The moles per letter thing will be cancelled. What's left? That is 1/second. So the unit of rate constant, K, is 1/second. Okay, 1/second. Or second exponential negative 1. It's just the same, right? So 1/second or as negative 1, our K, which is which for your good shot. K is equals to S negative 1, and then we have also 1/S. So this is our unit of K. The unit, guys, is very important because, you know, in the problem solving, the K will be expressed in the unit, and you can, in the K alone, you can identify that it's a zero order, second order, third order. So, madali na lang siya. So, that's why you need to determine the K unit. Because the R unit will not help because rate law have the same unit. Zero order, second order, third order, whatever, chupa chuchu. It's still per second, magud siya. Okay, so go on the K. And the concentration also is just the same. All throughout, moles per liter, molarity, molar. So it doesn't change. The only change in unit is the K. So go for K. Something like that, okay? Malong. So that's gonna be like that. Okay? So this one. This is the first order. Okay? Like that. I already showed the unit of K here in the zero order. Okay, now for the second order, it's here na ha. So n is equals to 2. So this is gonna be K raised to the power 2. So what will be our unit for K? So let's substitute na yun siya, mga values. Okay? To obtain the unit of K. Okay, so R, molarity per second, or molar per second. K is equals to, A is equal to moles per letter, or we can say that also capital M, right? Because it's just this. So molarity capital M, molar raised to the power 2. Okay? Now do the basic math for this. Solve for K. For high school or elementary mathematics. Grade school level. Charot. Okay? So K is equals to n/second, then n2. So the capital N will be cancelled somewhere along the way. So cancel the numerator to the denominator. What's left is capital N in the denominator. So you have to say this K is equals to, okay, cancels. This gonna be 1/meter, square meter, no, not meter, 1/square molar. Wow. Times second, square molar. Ano ba yan? Yes. 1/square molar. Like that. Okay. Then S. Right? Like this. This one. So let's do this again because we need to prove if this is 1/second, we need to prove this, and then we have M na lang siya. So we can say 1/S is equals to 1/M. Yes, this is 1/MS. Okay, capital M, capital S. Okay, this is our unit for the second order. Rate reaction constant unit is equals to 1/capital M times second. Now, it is also equal as molar -1 and S -1. If you want to try to put that in the numerator, it will be transposed. Okay, something like that in algebra again. Okay. It depends on you what your style, but it's just the same. Okay. Like that. So we have done only in the rate law, This is only the rate law. And then we need to go to our second learning outcome, which is the integrated rate law. This involves calculus already. Okay, so this is not easy anymore. But if you try to memorize the intake I1 to I27, okay, if you memorize the I, guys, you also memorize the D1 to D26, I don't know, I forgot. Derivation formulas and integration formulas. But here, since this is integrated rate law, so of course you will use integral, right? Am I correct? From the word itself. Because this is not differential rate law. This is integrated rate law man yun siya. So integral calculus will be used. Okay? So sometimes it's in the term. Okay? That's the technique also. Okay? So integrated rate law. So we need to use integration, basic integration. Okay? But I think logarithm and natural logarithm is still under algebra, right? Logarithm, natural logarithm, log and ln, or it's still part of differential or integral. Because sometimes also in differential and integral, it's involved ln, ln, chubu, chubu, right? You remember? For example, ln a b. If you try to integrate that one, ln a over b. Ganon. Ln a minus b. So it's gonna be ln a over b. Ln a times b, ln a plus ln b. Ganon siya, right? Remember? And then okay. E raised to the power ln is equals to 1. Logarithm to the base n, something like to the base n, and then b raised to the power m, like that, is equal to m over n. Ganun. Okay? Got the point? Again, logarithm small letter b, raised to the power n, okay, times, close and open parentheses, b again, raised to the power m, not n already. M and n man siya. So it will be equal to m over n. Your answer. So that is also a law. And then if we have also ln e capital A, or the constant, is equals to b, so it will become e raised to the power b is equals to a. The ln will be eliminated in the rule. Okay, so we need to apply that here to derive equations and formulas in the integrated rate law, something like that. Just like what we did in the Arrhenius equation, something like that. Okay, we need to derive. Okay, but here we need also the slope and okay, but the slope here is not necessarily the y2 minus y1, x2 minus, it's just only y minus y over x only, the simpler slope. Actually, that is the simpler slope. And y over x. Since we have two quantities manggod, mungkin siya mahimong y2 minus y1, x2 minus x1. But the basic is only y over x. That's the slope. Okay, it will just become y2 minus y1 because there's 2 points to consider. Okay, to undergo the parallelism between two quantities. It should be parallel. Okay, so following equilibrium stage, point 1, point 2 is in equilibrium with each other. That's why we need to equate point 1 to point 2. That's the reason behind why we have 2 points to consider in formulas and equations, or else it will not be happening like that. That's why we have ratio and proportion, interpolation, just because of that principle. Okay? Because if you cannot equate that one, if there's no steady state, okay? Steady state flow or equilibrium stage between point 1 to point 2. Okay, that means quantities 1 is equal to quantities 2 before you do the ratio and proportion, or before you do the interpolation, something like that. Okay, so there's a rule. Okay, if it is not having the same quantities, meaning temperature 1, temperature 2, pressure 1, pressure 2, that's what I mean. Okay, all pressure in both 1 and both 2. But if this is pressure and this is, you can never use ratio and proportion. You can never use interpolation for that. Okay, unless there's 2 points. Okay, 2 points from pressure and 2 points from volume. Then you can use interpolation. But if there is only one pressure and only one volume, how can you use? Okay, you can never solve for anything for that. Kwake. Kung sa kwarta pa, kwake. Okay, like that. For example, this is the spoon and the glass. Spoon 1, glass 1. You can never equate this one directly because spoon and glass is not the same. But if you have another glass in my hand here, glass 2 and spoon 2, then you can equate that one because these are all spoons and glasses. You get the point? Just like that. So that's the purpose of ratio and proportion, interpolation, and equating quantities 0.1 and 0.2. We apply only in the simple analysis. Okay, like this. The ball pen and the calculator cannot be equated because ball pen is not a calculator. But if you have another calculator and a ball pen in your left hand, then it can be equated because two quantities are the same. Okay, calculator 1, calculator 2, ball pen 1, ball pen 2. So that's the time you can apply the ratio and proportion and the interpolation. So the calculator means volume 1. The ball pen means volume 2. Ganon. So you can solve that. Okay, what is being required. And then the problem will say, what is the volume 2 of this? Ganon. Ikaw na yung bahala. So you know what I mean. Okay, so first, zero order integrated law. Okay, we will use the rate law in the basic one. K is equals to R is equals to K. So how can we do that? Okay, Laoy. You know, this is a very lengthy live stream. We will cut this one, right? Because I have still 8 items to discuss. Okay, integrated, integral rate law. Integrated meaning you fused, right? For example, integrated integrated standardization of international organization, ISO. Standardization of international organization. That's the definition of ISO. ISO 9001. Okay, then ISO 14001, ISO 18001 to 2007. Okay, that's 3 ISOs, meaning standardization of international organization. Organization of international standardization. Sorry. Okay, nabali. Okay, something like that. So, integration, meaning we integrate. Okay, something like that. So, first, buka na ko papel. Laoy, igutom jud ko in fairness. Okay, ganon ha. In this, katong mabutakad mo na limits, di ba? Limits, this one, initial and final, ganon. Okay. Na-substitute na yun mo. Okay? Like this. Guys, ang akong gi-memorize, mga 8 lang, gano'n lang siya. Because I don't like to memorize too much integral na integral. Okay? Like that. Okay. So first, zero order. Okay. K is equals to R. Guys, what is the definition of R? Chemical reaction rate or reaction rate. So what is really the specific chemical reaction rate? There's a numerator and there's a denominator. Okay, the word rate. Okay, something like that. Okay, so it's gonna be like that. So R, so D over dt. Ganun. D over dt. Okay? Then, the numerator will be your concentration because that is molar per second. So, molar. Molar means the concentration of the capital A. Here. The capital A. This is our concentration A. Then put that in numerator. So dA over dt. The T is the time. Okay? Like that. and t is the difference of dt is the difference of the time, and a is the different d is the difference of the concentration dA. Okay, something like this d. Okay, like this, a dA. Okay, like that. Okay, and then equal to this is r k. So we can say dA over dt is equals to k, or we can say also in another sources I found delta A over delta t, okay, equals to k. So delta and d is just the same. This used every time by the instructors and professors in college or even in the high school. D, small d, and delta triangle small are just the same. Okay, it depends on the comfort and convenience of the instructors or what books they are referred in their discussion. Okay, because it will vary to the type of books they are using. Okay, approach of presenting the the variable, the symbols like that. But I prefer the dA over dt because these are close to integral and differential calculus, right? Like that. Okay. Now, what is our rule for algebra? Algebra. Cross multiplication again. So dA over dt is equal to k. So it will become k times dt is equals to dA. Let's show why. Di na to ikalit, okay? Because some students cannot understand why it become like this automatically, okay? Unless we have a very high IQ or mathematical ability. Okay, so like this. So it will become dA over k dt. This one. So this is now our basis to have an integral rate law for the zero order n is equals to zero. N equals zero, huh? N equals zero, okay? First. Okay, now, so dA, meaning you have to have the, like this, integral, like a limit. So from concentration initial to concentration final. Your concentration final will be at the top, and your concentration initial will be your bottom. The initial concentration represented in A, capital A, small letter O. Meaning at time is equals to zero, because this is rate, guys, as I told you. Rate involves time. So when we put limits in our integral, something like that, in the bottom, we say A O or A zero. Actually, it's just the same. O is just starting point, or zero initial. Okay, like that. So A, let's just have O. Let's agree. The O means zero also, or initial. Okay. So A O at time is equals to zero. That's why we are saying A O. Okay? So, I put like this. Nga ni ba? Curve siya na taas. Nga ni ba yung mga integral, diba? So, this is at A, O. Concentration O. And then we need to put bracket. Because concentrations have bracket. Close and open parentheses. Okay? Like this. Okay. And then in the top portion, guys, will be the concentration final. We can just say capital A only. Okay? No need to put small letter F. In chemical kinetics, no need to put F. Unlike in thermodynamics, you need to put F for the liquid. Like, right? But here, no. So A at T. So at T is equals to 0 to T, meaning at certain time, it could be 1 minute, 2 minutes, 3 minutes, 4 minutes. That is our final T time. Okay, so A, then bracket, then T subscript outside the bracket. Okay, like this. A, like this. Okay, see? The T is outside the bracket. Something like that. Okay. Now, in the dt, okay, you have to put that here, again like this. What's the English for this? I cannot curve vertically downward. Okay? Like this. So dt will be also at t is equal to 0 initially, small letter ha, because this is not temperature in ideal gas level capital T, the Kelvin. This is small letter t. This is not temperature. Okay, this is time. Okay, so dt, right? So t is equal to 0 initially, so this will become TO. Okay, here. Okay, and then this will become T only at the top. T. T at T. At certain time, after 2 minutes, after 3 minutes, the final time covered after the chemical reaction has been completed. Okay, that's the definition for this. Okay, now let's integrate. Then we can say AT minus AO, right? Understand? AT minus AO is equals to T minus TO. So final minus initial. So I can say like that. Okay. So AT minus AO like that. Okay. Is equals to KT minus TO. This one. Okay. This is right. Integration, right? So, ganun siya. So, A subscript T minus this final minus initial. Initial AO is equals to K close and open parenthesis T minus TO. Final minus initial. Now, we finalize this. We will simplify this as like this. Okay, guys, at TO, common sense, at time is equals to 0, that's 0. Because that's initial starting point. In time-dependent situation, for example, in a 100-meter dash running competition in athletics, okay, 200-meter dash, 200 by 200-meter relay, athletics, for example, in Olympics, the time started is just equal to 0. Okay, that's why they will action like that. So that is T is equals to 0. And now if they reach the finishing line, that is the T. Just like that principle in kinetics also. We try to treat that as a chemical reaction, the running. Okay, so that we can understand clearly what I mean. Okay, the runner will position like this, and there's a gun, right? 1, 2, and then they will run like that. So before they run, position, that is T is equals to 0. And then if it's starting to run, that is the duration within, and then the final point will be the T, finishing line for the who is the winner, something like that. So that's our T final. It's just like that. So T final minus T initial, which is 0. So if T is equal to 0, of course that is 0. So we will cancel this one, 0. So what we left, guys, because TO or T initially is 0, what we left is this. So concentration of capital A with respect to time, okay, because this is a rate, that's why chemical reaction rate, time must be involved. Okay, that's very clear. Okay, minus AO. Okay, then this will become K over T. Okay, like that. Okay, like that. This one. Okay, now inspect the signs. Inspect the signs. Okay. There's a negative, there's positive. Now, compute for the value of A. What will happen? Let's play algebra now. Compute the value of concentration A final at T. So if this will become A T is equal to KT, di ba? KT, and then this will become, this negative, so this will become positive AO. Okay, like that. This one, AT, KT plus AO. Okay, like that. Now, guys, what will happen to our K here in this equation? What happened to our K here? Here. What's the sign? Negative or positive? Just for that. Okay, review this like this. Okay. Okay, this is negative. Why? Why? Why, Delilah? Why, Delilah? Because K and R is just directly proportional with each other. Okay? And then we assume in your reaction, A will produce a product B. Diba, guys? If A will produce a product B, ang A will become less concentrated, or the concentration will be reduced. So somewhere along the reaction, this will be negative. Okay, this will be negative. The A will become negative. Okay, and then if we put the negative here in our equation, it will be transposed to negative K. Okay, because our concentration will be always positive by standard man siya. Okay, standard approach. There's no such concentration initially that is negative. Malong? All concentration starts positive because it is not yet reacted, it is not yet reduced. Okay, just like as I have my, say I have $100 in my pocket. Originally, that is positive. Then if I have to spend that one in a market, it will become negative already because it has been deducted by $20. I buy caboose, I buy milk, I buy eggs. The principle also is just like that in this chemical reaction kinetics. So our A here, capital A to produce B, our A will be reduced, it will become negative. Then, since it is negative, it will transpose to the negative K. Why? Because originally, manggod, there's no negative concentration. So, if we divide that all with negative, that will become negative K. Okay? So, we have A T is equals to negative KT plus AO, right? Due to that principle that the initial concentration, it will always reduce to produce a product. Malong? Kinakuhaan naman siya, guys. So, negative na siya. Okay? So, that is termed also as the rate of disappearance. Okay, remember this. Because in problem solving, we'll ask, what is the rate of disappearance of nitrogen pentoxide? So you are solving for the concentration that will become less in your solution. Then the answer will be negative, something like that, okay? You get the point? If the question will say, what is the rate of appearance? That's the reverse. Meaning to say, it will be increased, just like the product. The product will increase because he will receive the concentration coming from the reactant. You get the point? So, arrow up. The concentration of the product will go high and the concentration of the reactant will go down. Kaya nanghatag man siya concentration to the product. So, our rate will be negative dA over dt, something like that. It will transpose to K somewhere around there. But in here, guys, why I don't put the negative yet? Because our rate law is just R is equals to K. There's no emphasis in negative at first. That's why in my solution, in presenting my derivation, I don't put negative yet. You understand the point? I have the equation. R is just equal to K. There's no negative there, right? You get the point? And then somewhere along the way, I started to incorporate the negative due to the principles and concepts and theories behind. In actual, if you have a chemical reaction that will produce the product, that's why I explained that it will become AT is equal to negative KT plus AO. Now, guys, what the unit is for this equation? Is this a polynomial equation? Polynomial, monomial, binomial, what? Quadrinomial in algebra. Dealing with polynomial. Okay? That involves variable. What's this? This is a slope. Okay? So we use the y is equals to mx plus b. We cannot use the quadratic equation in here because there's no exponent in our general formula. Because we have also the quadratic equation minus b, okay, plus and minus, then the square of b squared minus 4ac over 2a. So that is our quadratic equation in polynomial, right? But in here, there's no exponent, so we cannot use the quadratic equation. Instead, use the slope. Y is equals to mx plus b. So I will put now y is equals to mx plus b. Okay? Don't be afraid that our slope, there's no negative m in our original equation of the slope. Okay, because should be adjusted now in this at minus kt plus ao. So our slope here now is negative k because this form is the same as y is equals to mx plus b. Our y is the concentration A subscript t. Our n slope is negative k. And then our b is AO. So, ganun siya. That's why, guys, negative k is a slope or k. Because sometimes it will become positive also somewhere along the way. It depends on the theory. Okay? So, k is a slope. It could be negative, it could be positive. So that is M. That's why we need graphical representation to illustrate that easily. Okay, so that we can understand what will happen if I will increase the rate constant. What will happen to my concentration in A? What will happen to my time? If I will increase the time, what will happen to my reaction rate? So that's the purpose behind, so that you can understand the behavior, okay, of these quantities in a graphical representation. And that's the time you will plot the y-axis and the x-axis. Something the same as before in the, in the Arrhenius equation, the Arrhenius theory by Mr. Svante Arrhenius in 1896 to 1980. Grabe, no? Okay, like that. Or shall we say 1896 lang siya? Because we don't know really if this is true. Kaloka. Okay, Svante Arrhenius. Okay, like that. So, I'll just break down so that we can understand very well. So, m is equals to negative k, y is equals to a, okay, and this one, what's this? Oh, b is equals to AO. Guys, our initial concentration here in the graph is not the concern. It's always the final concentration, okay, in the graph. Of course, it should be the final concentration to plot. Plot A versus K. Ganon. Plot B, AO versus Y. But in here, only the Y and the A. The A and the K, sorry. Because the Y is the A. Okay? Vertical axis, Y axis. Okay, ganon siya. Chucho. Okay. And now we go to the second, first order na. Integrated rate law for the first order. Laoy. Talaga. Okay. Guys, first order n equals to 0. So I have, where is that? Here. This one. This one, R is equals to K times capital A plus open parenthesis raised to the power n. Okay, this is our first order reaction or first order overall reaction. In here, the overall reaction is just equal to the individual reaction because we have only one reactant. This is a unimolecular chemical reaction. Okay. Now, be careful in the terminologies. You should understand each terminology if you study chemical engineering so that you know this is a unimolecular chemical reaction, bimolecular chemical reaction, trimolecular chemical, so that you can determine in the problem solving. It's very easy for you to understand. Okay? So employ the terminologies, breaking down of terminologies so that you can understand. So it is English versus mathematics. Okay? Like that. So the interpretation of the English terms, you can understand it clearly so that you can have an appropriate equation and formulas to be used in a particular problem. Something like that, okay? Because a lot of terminologies will be changed like that. For example, I have a problem that will say the molarity. What if the problem will say the solubility? It's possible also in the chemical reaction kinetics that it will state the solubility. And solubility is just technically equal to the concentration. Okay? Concentration is a general term. Solubility is a general term. Concentration composed of molarity, molality, normality. That's concentration. It is also a solubility, normality, molarity, okay, and molality. Now, if you are not familiar with the solubility and the concentration, sometimes you will mix up because other problems will use the solubility in kinetics, in which that is not more used all the time when we are in college. Okay, we are always using the concentration, the molarity, but sometimes solubility, just like the Henry law in partial pressure of the solution, Henry's constant, okay, Henry's theory. Remember that one? Okay. Now, in the Henry's law, the partial pressure of the solution is dependent on the constant, Henry's constant, or the solubility constant. Okay, sometimes it will not use also the word solubility. It will just also use concentration somewhere out there. And then we are used to that the word solubility is always there. And then we will be panic. What's this? I don't need this one, but it's just the same. Only changing the word solubility to concentration because it's just the same. Concentration and solubility is equal technically. Okay? Understand the point? Okay, but before in my college, I did not understand this very well regarding solubility and concentration. Okay, just now when I have my thorough, research, reading, something like that, review, plus stock knowledge and some sources, and then I come to find out, oh, it's gonna be like, oh my gosh, if I know this before, what will happen? Shut up. Okay, maybe I could have a higher grades in my subjects, or maybe like that. Maybe somebody will say, you are arrogant. No, really. Okay. If I will say something, somebody will say arrogant. Okay. Okay. Because honestly, I am a champion of chemistry quiz ball in our school when I was in high school. Okay. That's why I represented to the science competition. I told you a while ago, right? In the University of San Carlos, Talamban. Okay, something like that. Okay, and then I memorized all the terminologies in chemistry when I was in high school. And then when I go to college, it's stuck already in my brain cells. Okay, then plus the additional, then it will become compiled more and more and more like this. Okay, so I did not found difficulty in chemistry when I was in college. Okay, something like that. So it really proven because my grades in chemistry are a little bit higher. Okay, in all my sciences subject, chemistry is the highest. Okay, something I love really chemistry. I love science as a subject, but specifically the chemistry part. Okay, something like that. Okay, and then really when I was taking up the chemical engineering examination, I really want to become a top notcher. Really, somebody will say you are very very arrogant. I have to tell the truth. I don't have to be hypocrite. Okay, hindi ko magpakaroon nun. Huwag na ako siyang i-target. Okay, why should I will not tell the truth. Okay, I should tell the truth. That is not my aim before. Okay, because it doesn't mean that you are a cum laude or whatever. You will never aim high. To aim high is for everybody, guys. Okay, even though your intelligent quotient is not so high, you can still aim to become a top notcher because that's only aim. Okay, aim meaning abstract. It doesn't project to reality. It doesn't project to an actual result. That is only aim, goal, and objective. If you aim high, possibility you will pass. If you aim to pass, possibility you will fail. So you should increase your goal and objective so that you're somewhere along the way in the average and above average of the result. So that's really my aim when I was taking the word examination. Okay? I'm just, disclaimer lang kasi po, maybe they will tell I am arrogant. Okay? Like, or boastful or whatever. Okay? Then, I don't have to lie, right? Okay? Something like that. So that is the K to pass certain examinations. Okay? Now, that is for the first order, right? Our first order, guys, going na ta, integrate na yun ta. Okay. So, like this. So, K. So, R is equals to K, capital A raised to the power 2. Oh my gosh. Now, rate is equal to dA over dt. Again, the same as a zero order. Okay, so D. Guys, in here, we will incorporate automatically the negative half. Okay, because this is what we did in the zero order to make it short. Because the tendency also, we will forget. Okay? Because I told you over and over again, this is not scripted. Okay? So dA, dt. Okay? We will put again directly negative. The rate will be negative because it is going to the reaction man siya. Okay? Negative dA over dt is equals to K concentration raised to the power 2. Okay, guys? Ganon. This one. Okay. Second order mo din, first order pa data, sorry. Nagdali, di ko gutom, magod ko. Guys, you will feel hungry if you're a lot of, in your mind. You think a lot and then talking, thinking, what next, like that. So it's also make you hungry. Just like singing. When I do a lot of singing, I'm hungry after. Okay, something like that. Because it's also gaining energy. Your brain also consumes energy. Okay, that's why my mouth consumes energy. So you keep on talking, you'll become hungry. And you keep on thinking like this, and discussion also thinking the formless equation. Your brain also consumes energy. That's why, and then it will send signal to your digestive system. Okay, and then it will be hungry through the hormone, specific hormone, right? Could it be the serotonin, melatonin, mga ganun siyang hormone a lot, right? If you study about biology or biochemistry, remember? We discussed that before, the different stress hormones, like that. Okay? So, ganun siya. Okay? Okay, negative d over a over dt. Okay, let's integrate this one, guys. Guys, the ka over 1 raised to the power 1 is just ka ha. Okay, so the negative dA dt is equals to ka. Okay, now this one, equation. Now, integrate. Okay, put a curve vertical like this for the both sides, like this. Okay, now the same story you will be able to do, huh? Okay, and then crisscross multiplication. You know crisscross? Okay, but before you do the crisscross multiplication, guys, nainisamok na A sa tupad sa K. Our purpose always, God, in derivation is to simplify the thing, especially you are trying to obtain the specified or required, this quantity. So the one besides that quantity, you need to cancel that one because that is the one you find out. So that's really the technique so that you can be able to have a simplified equation. Now, like this, okay, like this, okay, there's a beside the k. So we need to alter this one. So multiply the both sides, all sides with 1 over a. Para mawala ang a, samok man siya, tupad man siya sa k. Okay? And remember that also, that the partner of the k is not the concentration in your analysis and theories and concept. It's always the time. Is that the point? Because it's not related to the concentration. Then dili sila magtupad. So you have to delete the a. So that's why you need to multiply that 1 over a so that k alone will remain. Okay? Okay? And then somewhere along the road, the crisscross multiplication, that's the time t will arrive besides the k. Meaning to say, the k don't like a. He or she like t. Okay? So, gusto siya, majowa niya ang temperature, dili ang concentration. Okay, di ba niya patuparon kay cancel mo niya somewhere along the way. So, ang rate constant o ang time, jowa. Okay, ganon. So, multiply with both sides. Just like proton and neutrons. Proton and neutrons are banded together inside the nucleus. So, sila ang jowa. Dili ang electrons. Okay? And then, kinamugos man si electrons, iya yung ijuwa ang proton, malagpot na sa ang proton, magbuwag, mag-divorce ang proton ug ang neutron. Muna, ang magkauyab in the end, ang proton jud ang electrons. That's why we have the law of magnetism, the polarity theory, and the law of electromagnetism. Okay? Like discovered by Mr. Peter in 1889. Okay, that's the time we have the equation Debye-Hackel-Onsager equation. Later we will be discussing that also in after 2 days, after 3 days. I still have to polish that, the theories and concepts because that was too long ago when I graduated in chemical engineering. That was 20 years ago. Okay, so I have to, though I have already the stock knowledge, I have to polish something like that. Okay, so that it can save time for me also in the discussion. Okay, so negative d over d is equals to k over a, k times a. Okay, now 1 over a. Ganon. So cancels the. Okay, both sides shall be multiplied. So that's the rule in algebra. So it will be cancelled down. So this would become k alone. Okay, k alone. Okay, so here in the rate, it will become negative dA dt times 1 over a. Malong? 1 over a. Ako lang butang dot class ha. A dot, a period, a close open parenthesis, and a times x, small x, is just the same with multiplication operation ha. Dot. That's multiplication in algebra. Dot, period, close and open parenthesis, besides with each other. And then sometimes in the keypad, in the Excel, we have the asterisk as our multiplication. When you do the formula in Excel sheet computer, so that's also multiplication. But that's applied only in computer, in the keypad, in the Excel format. Okay, if you write a formulas there. Okay, so it could be a times x, small letter x, a period, a dot, and a 2 close and open parentheses or 2 brackets putting besides together. Those are operations in multiplication. That's very clear. Okay. Okay. Now, this is the time you will be able to cross multiplication in the rule of algebra. Meaning you have to put x like that. And then this one will multiply, and this one will multiply like this. Okay, that's cross. Right? Or the other way around, you need to input the other, but I don't like the other one that you have to put. You divide this with something, so it will be left. I don't like that one. I like the crisscross. It depends on you, huh? Okay, like this. So if I want to crisscross this will become like this. Okay, negative 1 over A dA, okay, is equals to K dt. Pares na yun ang temperature ng K. So, jowa na sila. Okay, like that. Okay, so, negative 1A dA K dt, integrate both sides. Again, the same principle with, ganon, chupa-chucho. The same principle with, what is called this one? Zero order. Now, guys, in this case, if you have a dA over A, you cannot apply the numerical, algebra here because that is dA over A. So we can apply the calculus for this. Okay, like that. dA over A. So we need to use the natural logarithm. If you have that dA over A or like that, okay? Because it's the same, A and A. There's a rule for that. So this will become ln, okay? ln A, something like that. Okay, because this is dA, okay? Like that. So this is ln, because dA over A is equals to ln. Okay, natural logarithm. And then, so we will need, since this is final and initial, so ln concentration A at T0, this is AO, so this is ln AO, or A0, initial, and then final ln A at the top. Okay, like this. So, okay, ln concentration A at the top, and then at the bottom will be concentration at T is equal to 0, or initial concentration. Okay, and then the other side. Okay, the other side is K dt. So it's just the same as TO and T at the top. Same with the zero order. Okay, not too much issue with the K. Okay, like again. So we have the rule in integral calculus that if ln like this, we need to subtract. Okay, so ln, okay, ln final ln A minus ln AO is equals to K times open and close parentheses T minus TO, the same in zero order. So TO will be cancelled because T at zero man ng TO. Okay, so T na lang siya. So KT. Okay, so this is ln, okay, A minus ln AO is equals to KT times KT at KT. Okay, small letter, small letter K, small letter T. Okay, like that. Okay, now there's negative here. For me, guys, I don't include the negative here muna ha because it mulubog siya. Okay? Adto na niya nato siya isamok at ibutang ini kalash. Okay, dili na kay siya pag-divide. Okay? Something like that, okay? So, never consider the negative yet. Okay? Just later. Okay? Like that. Now, solve for the value of ln A because same with the zero order, our A will be our y-axis in the graph. So this is ln A transposed is equals to KT here, like that. ln A, KT, okay? And then transpose negative ln AO, positive ln AO. Okay? Now guys, i-employ na nato ang negative sa rate. Negative dA over dt sa rate. Employ na the negative sign. Okay? Employ. Okay. So, divided by all with negative, it will become negative, right? So, negative KT. Okay? Like this, negative. Charara. Okay? And then, this will become, finally, ln A, negative KT plus ln O. Okay, like this. This is the final formula for this. Okay. Why it become negative class, the K? Because our rate is negative, the dA over dt. Okay, like that. So that's one. If you solve that one by one, it will just appear also. No problem. Okay. Justification of the signs. You can have also. Because I saved the paper. By the way, that's very easy. Okay, that's high school mathematics or elementary mathematics. Okay, like this. Okay, so negative kitty. So our final for the first order, guys, will be cast even paper. Okay. Mn concentration of A final. Okay. This one. First order, n is equals to 1 is equals to ln. Okay. Concentration of A is equals to negative K times time plus ln AO. Okay. AO or A0 is just initial concentration. Capital A is final. At T. I never put the T because it's understood at time T, meaning at any time T. Okay, like that. Okay, this. So our y is equals to mxb. So y slope. Y is equals to mx plus b. This one. Okay. Like this. Okay. So, kining y is equals to mx plus b. Ay, yun yung kalimiti, guys. This is discussed in the elementary level, grade 5 or grade 6. Memorize that in your brain cells because it will be used again in the college. Okay? The slope thing. Okay? Because this is elementary mathematics. The elementary mathematics will be always used in higher, level of course in college. Okay? Something like that. Because this slope is gas-gas na jud kini siya nga formula. Okay, so y is equals to mx plus b. So y is equals to ln A. Okay. Like this one. Y is equals to ln A, meaning y-axis in your graph. Okay. Now our m slope is equals to negative k. Okay, here. Negative k because it's still the same in format. Okay, so negative k. Ganon. Our B class is AO, LNAO. So our B class, constant B, is wale. Bakit wale? Because hindi naman siya kailangan sa graph. So wale. We don't include, but for the purpose of discussion, we need to identify that this is the constant B. Okay. Maybe in the problem solving, we'll ask also, what is the B in the first order reaction? So LNAO, answer. Okay, which is possible also. In the first order reaction, what is the value of constant B? Not alone, in this discussion of the equation. A, like this, B, like this. So your answer will be LNAO. Okay, so wild imagination. Okay, like this. So, quality of being an engineer to have a wild imagination plus critical thinking. Okay, it's gonna be like that. So it's gonna be LNAO. Okay, ganun na siya. We don't need to graph yet because it's in our part 5 of discussion. Wait, we need to see my learning outcomes of this live streaming. Okay. Oh my gosh. This one. This is our learning outcomes. So in item number 6 that we will be able to discuss graphs, all about graphs. We are still in number 2 pa, integrated rate law. Let's check comprehension. Item 1, class. And item 2, okay. And then we will finish everything, okay, later. Okay, now, so it's gonna be our equation for the first order reaction. Ln concentration final A is equal to negative T times T plus LNAO, the graph. This is at n is equal to 1, or reaction, overall reaction order 1. Okay. Okay. Now, overall reaction 2, n is equals to 2. Okay. Now, again, integrate. Now, we have R is equals to K times A raised to the power 2, because it's a second order, like this. See? Guys. Okay? I told you frankly, this second order, there will be a little bit of confusion. I'll tell you later, okay? Because there's a, it will suddenly go to the denominator, it will go to the top, and then this is the time you will use your logic. Why? Okay? Something like that. This is gonna be the situation. Okay? But wait. Okay. R negative dA over dt is equals to KA2. Ganon. Okay. Integrate. Okay. So, okay, before integrate, cross lang muna. So, negative dA equals to K A raised to the power 2 dt, right? Ganon. Cross multiplication in algebra. Okay? Like that. Now, Ka to the 2, okay, namok siya. Okay? So, cancel that A to the 2. So, the whole thing will be divided by 1 over A2. Okay? 1 over A2. Okay? Your technique here, guys, is to make simplified the constant part. Okay? It will just become only KT and somewhere along the way. So, that's why I told you, mag-jowa silang duha. Because K and T will always partner with each other sa equation. Okay? Para K times T lang yun na yun. So, muna yung technique. Okay? And the one you multiplied, dito siya masabak sa reactant. Dito na ka mag-integrate pag ayaw. Applying the rules of... Ako na lang ibisaya ka. Mumila siya. Okay. Now, so this is negative. Cancel. Negative dA over K, like that. So this will K dt. Now, guys, dA2. What do you observe? Simplify this dA over A2. The capital A cancels the A in the downside. So cancel A. So what will remain is the D. Okay, like that. D over A is equals to K dt. Okay, guys? Guys, this negative dA is the parallel, the same story with the zero order. The zero order lang din siya, guys. Ang capital A is in the numerator. It's negative dA. Now in here, negative D over A. So understood, it's gonna be 1 over A. So you will expect 1 over chupa-chuchu in your final equation. Okay? Unlike the zero order, there's no A in the denominator. So you will simply like this, A minus like this, ting, chupa-chuchu, because there's no denominator in that particular aspect. Okay? So here, so integrate. Our limits will be again the same thing. So, AO, like that. Okay? So, we can see that 1 over A, ato siyang igawas daan. Okay? This D over A, pwede mo na siya 1 over A, D. Right? So, that's why 1 A, atong limits, 1 AO, and it's A at small letter T, and then the KT, the same story. Okay, T, O, T. So the integration will be happening like this. Now what about, guys? Okay, tutuki. Okay, just take a look for the second order, reaction order. Okay? Very clear, huh? Okay. The limits will be from the concentration AO, again the same, and then AT. And for the time is T at 0 or TO, and then T, okay? And then do the integration, something like that. Okay, now, so since that's it, 1 over A, you will never say A minus AO na. You will say 1 over A minus 1 over AO because this is 1 over A man siya. Reverse siya atong zero order. Okay? Ganun siya. Now, guys, magkatawa dyan ko, ano yun. Kunyara na ako ilang put, ha? Ini ka, kung ano, last. Mukalit ragid niya siya because the logic will be applied, okay? Later. Okay. This is gonna be 1AA. Okay. 1A minus 1AO is equals to KT. Because TO is just equal to 0, automatic cancelled in the equation. Yung jowa ni rate constant. Okay, tupad na sila Fermi ni rate constant. Okay? Di sila magbuwag. Malong? Unless time is being asked on the problem. That's the time si rate constant o si T magbuwag na sila. Okay, but now, still jowa in the general equation. Okay? Okay, partner silang duha. Okay, now this one. Okay, this one. So, guys, di ba negative 1AA? So let's put also negative here in the 1AO. Here. This one. 1A minus 1AO, then there's a negative outside because this is not negative 1 over A man siya. Okay, so negative. Ganon. So negative times 1 over A, negative times 1 over A is equal to negative 1 over A. Okay, negative 1 over A. And then negative times negative, okay, this will become negative 1 times 1AO, it is positive. Positive 1AO. Okay, because negative, that's positive in algebra again. Then KT. Okay. Now, nakakaloka. Okay. So this is, we need to divide all by negative so that we can attain a 1 over A because this is our y-axis. We don't have a negative y man in our slope. It's always positive y. Okay, and then it's also positive in the y-axis, not negative. So we need to cancel the sign of 1 over A. Okay, so divide all with negative. Anyway, let's go back again if sayop ang atong analysis, ha? Okay. Because as I told you, this is not really scripted. Okay, negative. So, okay. Negative 1A divided by negative, positive 1A, right? 1 over A. So, positive 1 over A. Okay. 1AO divided by negative, negative 1AO. Lawe. KT divided by negative KT. This one. Okay? Okay. Now, solve for the value of 1 over A. So 1 over A is equals to negative KT plus 1 over AO. Now, I told you. Now, this is A, right? A here. Kanisa. A. If ang A isa ka ni mo balik sa numerator, it will become negative. Okay? It will become negative. So the rate will be negative. Right? Now, again, divide the whole thing with negative. So the K will become positive. So this will become 1AA minus 1AO. Okay? Is equals to positive KT. Na. Okay, this is our general equation. 1AA minus 1AO is equals to KT. Or we can say that as that 1AE is equals to AO. Or 1AA is equals to positive KT, okay, plus 1AO. Okay, ganon-ganon. Okay? Okay, guys? So this is our second order. Guys, 1 over A is equals to K times A plus 1 over AO. What do you notice? The K is positive, right? So in this, of all the reaction order, the second order is only having the negative slope of all, 0, 1, 2. Only the second order have a positive slope K. Okay. Okay, remember, memorize na K is always positive in second order in the integrated rate law. So Y is equals to 1 over A, M is equals to K, and B is equals to 1 over AO. Okay, this one. In the equation, Y is equals to MX plus B. Y is equals to 1 over A, M is equals to positive K na, and B is 1 over AO. So this is our second order. Now, if you have these formulas already, you can apply this in a problem solving. Okay? That involves chemical reaction engineering or chemical reaction kinetics. How fast and slow the chemical reaction is to undergo a complete reaction. Okay, something like that. So that we don't need to add catalyst. Okay, because if you add artificial catalyst or any catalyst, that also adds additional cost in your system or process. So we need to avoid that one. Okay, that's why we need to refer to the natural chemical reaction following this integrated rate flow language siya without altering the components like this, without adding a catalyst, without what else? Without changing the temperature, without changing the pressure, of course, because these are not dependent with temperature and pressure. Nakakaloka, no? Okay? Something like that. So, after that, we will recall those y values, slope values, because that is, or our x values, because we need that to graph. Okay, like that. So our x, right, y is equals to mx plus b. Our x-axis will be the slope. Okay, like that. And our y will be the concentration alone, not the initial, the concentration final. Okay, A. If we mean capital A, that is final concentration. Okay, like that. Okay, so done na tayo sa integrated rate. Now we go to the half-life, number 3. Half-life. This is the half of the time it measures for a certain initial concentration, okay, to proceed in the chemical reaction. Half of that time duration, okay, to proceed the complete reaction, chemical reaction, okay. Because it's in the half scenario, we can balance everything. Okay, not on the last part. How can you balance? You are now on the last part. You will never know the initial and the center. Just like in the strength of materials or engineering mechanics, we need to determine the central point or the center of gravity in which all the weight will be concentrated there. Or else your bridge and your building will collapse if you did not consider the center of gravity somewhere along of your construction or the centroid, just like that concept. That's why in here we need to determine the half-life because chemical reaction kinetics is time dependent. That's why half-life. In just the same with civil engineering studies in engineering strength, engineering materials, okay, strength of materials, we need to consider the centroid, center of gravity in construction of a bridge or construction of a building. Just the same like that. But in here, chemical reaction lang siya. So that's why T half or half life. Okay, in a chemical reaction point of view, not in the bridge, not in the like that. I'm talking only for the analogy, comparative, so that we can understand what I mean in here. So if we will not determine the half-life, then our chemical reaction will not also proceed uh, fast, and it will become imbalanced, just like the bridge. You determine the calculation of the centroid and the center of gravity. Just like here, we calculate also the half-life in chemical reaction. Okay, you know now what's the purpose of half-life, right? To determine the completeness of the chemical reaction. Without half-life, then we don't have bases. Okay, that's why this is time dependent kasi. Actually, there's also half rate low. Why not half rate low? Half rate constant. Okay, because these are also the quantities, right? Rate low is equals to the rate constant and the concentration is over 2. Why it is not also half concentration? Why so special? Always the time, half life. Life is time. Okay, like that. So why of all quantities the time is being considered? Because this is dependent with time, this chemical reaction kinetics, because there's a time in the denominator of the chemical reaction rate. So dependent with siya sa time. That's why the graph have time, like this, whatever, concentration and time. Remember? I forgot to stress this, no? In the basic rate law, not the integrated one, not the integral rate law. In the basic rate law only, we need to graph the concentration versus the time. That's why. And we obtain a lot of types of graphs. I will discuss you later in the chapter section 6 that talks about graphs. I don't want you to be confused that I will mix up with graphs. Graphs, all discussion, something like that. Okay. Now half life. Okay, half life. Charot. Half life of let's say uranium. Compute the half life of a uranium after it before it will be decayed after 32 years. Okay, remember that one topic in nuclear chemistry? You need to determine the half-life of a certain element during it will decay. So most of the radioactive materials and substances under the actinide series and lanthanide series in the artificially prepared elements, or what we call the radioactive materials in the periodic table. So those are actinide series and lanthanide series, right? Okay, memorize those: uranium, thorium, plutonium, ganon. That will be used in X-rays, right? Or beta and gamma emission. Okay, that's why we have X-ray tests. Okay, test of the radioactivity or radiation in terms of the unit will be, as far as I could remember, micrometer, the wavelength of the radiation, or the nanometer, small letter n and n. Nanometer is the wavelength unit, or the micrometer, or it could be also, I forgot, micrometer. Okay, something like that. Just like in screening, right? The tiny particles, the unit of that is just the same. But it's more lethal because of its radiation. Invisible in our naked eye. Siya, mga rays, alpha rays, beta rays, gamma rays, o ganon. That it will penetrate even though to the lead, L-E-A-D. It will pass on that strong metal lead. Imagine the wavelength for the radiation. Okay, if you remember alpha, beta, gamma ray, X-rays and the laser, light amplification, separation, emission, radiation. That's the term for laser in the operation in medical technology, for the operation of the heart, liver, kidney. So nowadays they are using the laser technique in operation. That's costly compared to the physical operation that you have to cut the stomach, and then so laser is the most widely used now, but it is expensive but worth it. Okay, because you will not feel painful and you don't have scars after the operation. Okay, like that. You get the point. So it's better to undergo laser, but only costly is the issue there. Costly. Okay, but never mind. That's really life all about. Okay, so half life. Laoy. Okay, I have still 20 minutes more. Then we have a break for the second segment for this live stream. Okay, let's talk about half life. Okay, so half life is represented in the symbol T raised to the power one half. Okay, oh my gosh, it looks like very difficult because the exponent is one half. Charot. Okay, another paper, please. Charot. Okay. Nakakaloka. Okay, half-life. Now, half-life, guys, is inversely proportional to the rate constant. Okay, as you can notice in the first law, or the first order of reaction, zero order of reaction, okay, first order of reaction, the K is always in the denominator, in the T1 half formula. Okay, always in the denominator. Meaning T1 half or half-life is always inversely proportional to the rate constant, regardless of what reaction order. Okay, meaning to say, if you increase the rate constant, your half-life will be reduced. Okay, then you have to increase your rate of chemical reaction. Okay, something like that, right? So half-life T 1/2 is inversely proportional to the rate constant. Okay, something like that. Since we have the R, K, A, let's see first order then. Solve for the value of K is equals to R over A. Since rate constant class is directly proportional to the rate law, R is directly proportional to the rate constant, or chemical reaction rate, or rate law. Always remember this class, ha? These three terms always used interchangeably in the problem solving. Okay? Rate law. Another name, rate of reaction. Rate of reaction. Another name, chemical reaction rate. Because sometimes the problem will never say rate law. Okay? We just say the chemical reaction rate of nitrogen pentoxide is like this, but that is rate law, the small r. Okay? So that you will not be confused. Masters the synonyms of the formulas. Synonyms. Pareho ba? Okay? Because they will use that anytime they wanted to. Okay? Especially old books, old books. Old books are using the old terminology also. Really. For example, grams per mole in the molar mass or the molecular weight. Some books I studied before when I was in college, they will express the unit in molecular weight or molar mass in terms of grams per grams atom. Gram atom, and pound per pound mole. Okay? But it will not be applied today because it is already pound per mole or gram per mole. But actually, if you try to understand just like the same, in every 1 mole, okay, there's also 1 gram of a substance like that. So they put the gram beside the mole. But to make it more precise, that is grams per mole, because the students will be confused adding grams beside the mole. Okay, there's a dash. Grams per gram dash mole. And then pound per pound mole. Something like that. The unit of molecular weight and molar mass. But some books, or more of the books, using they delete already the grams in the denominator. Okay, that's what I found in the library before, because I have so many sources. I'm not contented with other one book only. Okay, grabe, old talaga yung ibang books. Very obsolete unit will be used pa. Okay, so it's action. Okay, guys, especially chemical engineering students, go to the latest Paris Chemical Engineers Handbook. The 9th or the 10th, something like that, edition. Okay? So this one, since the rate law, guys, or the rate of chemical reaction or the reaction rate is directly proportional to the rate constant, then I said a while ago that this half-life is inversely proportional to K regardless to whatever reaction order. So meaning to say, if you increase the rate constant, okay, automatically your half-life will reduce. If you increase also your chemical reaction rate, your half-life also will reduce because the same thing. Because because R and K are directly proportional with each other. Like this, okay? So, mugamay din ang time. Okay? Time will always be reduced if you increase the rate of reaction, okay, the rate constant. Okay? But the concentration here is not mentioned. And now let's go to the relationship with the concentration. It's in the second order and the zero order that the concentration matters in the half-life. Okay? Because in the first order, the concentration, the initial concentration is not considered. Okay? So, ana pala siya, guys, if you read the theory and the introduction in the book, chapter to chapter, you need also to scrutinize the relationship and then apply that in your formula. What will happen to this if you increase like this? What will this? So that you have an idea already that your answer will be valid or logical or reliable. Hindi lang kayo solve lang yung me. Okay? You need to assess how valid, how acceptable, how reliable, how logical our answer really is that meets the basic theory and principles of that particular topic. Something like that, okay? Or else you defeat your purpose. That's why you study that one because of the theory and principles. It's not the problem solving that matters a lot. It's the theory. So you understand what will happen if you will do this, what will happen if you do this, meaning you have to explain, you have to think, you have to reason out like that. It's always the reasoning. Man, go, di man go ng compute. Really, it's not the computation. It's the way how you reason out, okay, based on your analysis. The computation is just to solve sa mo, nitabo na akong calculator. Ano ba? So that's thinking, reasoning. We don't have to compute for the diameter of this calculator just to answer that question. Is that the point? Okay. Of the calculator. Okay. So I have to think that it will be fitted when I close this calculator, the cover. Then I have to act and see by my eyes through reasoning. I don't have to compute the diameter of the calculator now just to fit the cover of the calculator. You get the point now? Okay, so the theory comes first. The numbers are the problem, so we will just follow, just to prove your theory and principles to be true and coinciding with each other. That's why all scientific research comes first with the theory, data gathered, not on the equations. It will just follow after a series of data experimentation that your equation and formulas will be used, applied. Okay? It in the last part. So you have a law. Okay? All law, Arrhenius law, Dalton's law, like this, meaning an equation and our formulas. Meaning the conclusion of your scientific research or study or discovery has been proven and tested na talaga siya after your conclusion or summary. So you have your equations, formulas. Albert Einstein, a theory of relativity. Energy is equals to mass times the speed of light raised to the power 2. That would be your conclusion and summary of your discovery regarding energy with respect to the mass of the object and the light speed of light. Okay. Just like with Newton's law also. So the equation to be the last. Okay? Like that. Okay, but what happened? Most of the engineers are loving too much with computation. Okay? There's a lot too much intelligence in solving, but when you ask something they cannot answer. Really, this is my true confusion. For example, there's one chemical engineer will ask, "Oh, my friend, what is Le Chatelier principle?" He cannot answer. But if you give too much problem solving regarding Le Chatelier principle, he can solve a lot. But he doesn't know the theory comes first before the solution and the problems. Okay? Like that. Okay? Then somebody asked me also, so to explain what is Le Chatelier's principle. And he tried to test me only. Okay, but then I asked him correctly something like, because that's already basic in our first, in high school, in chemistry high school, right? And it will come again in the college chemistry. Okay, in the engineering subject, something like that. Okay, in first year, guys, supposedly you will memorize that stuck in your brain cells. Okay, okay, going back here. Okay, this is the relationship for the half-life. So T half-life or T1 half, zero order. Ganun siya. Guys, in the sources or even in the chemistry books or the PhChem book, physical chemistry books, okay, the details there are not explaining how to derive the T half-life. Really. But I don't know where are the sources for that just to derive, to come up with the equation T1 half is equal blah 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 chuba chu chu. Okay, so what I did in my college years, I just completely memorized immediately without deriving, because if I keep on going to other books, it doesn't give a simplified derivation and mix with the statement. I cannot understand also. And until now, this T and 1 half-life, I couldn't find a derivation for this. Can you suggest what types of books I will refer to this? For the, how can we derive the half-life formula of zero order, like that? So what I did, I memorized siya automatically. Okay? So T1 half for zero order is equals to, okay, like that, is equals to the initial concentration AO over 2K. This is based on my memory. Okay? Not on derivation, okay? Because we will learn also if we derive, right? To be honest. But it just happened. I don't see the derivation part. Okay? So AO over 2K. And then this is the zero order. For the n is equals to 1. Very easy. T raised to the power 1 is equals to, okay, ln2 over k. Okay? This one. ln2 over k. So, divide siya. So, 2 ln. ln2. Okay. ln2 over k. Okay, first order. First order na siya. Second order, T1 half is equals to the reverse of the zero order. So that is 1, okay, over EO K over 1. This one. That's why I told you guys, in these three equations of the half-life, only the first order has no correlation with the initial concentration. Meaning to say, the half-life computation of the first order chemical reaction doesn't depend on the initial concentration. Okay, the same with the rate law of the zero order doesn't depend also on the initial concentration, but that was the rate law in zero order. But here it is in the half-life. You memorize that one correlation, okay, we will come out to the examination. Okay, like that. And it will help a lot also in your analysis, in the problems. Really, you have no idea after trying, oh, we treat this as ganon, ganon. So, madali na lang siya. Okay? Okay. Ganon. Okay. Okay? Please register in your brain. Okay. Like this. Okay. Half-life finished. Now we go to this item number 4, reaction order. We have to emphasize that. My gosh, it's a little bit, a lot of reactions and then reaction mechanism, reaction 1, reaction 2, reaction 3, reaction 4, reaction. Actually, guys, I love chemical reactions that's why. Since high school. That's why I can usually predict what's the product. Okay? That's not to be arrogant, not to be boastful. I think I passed chemical engineering just because of that. I love too much chemical reactions. Okay, hence like that, and I love memorization. That's why. Because it's not enough really if you don't memorize. Okay, a lot of memorization. Okay. In fact, I come to the point that I memorize the way how it is being solved. Okay? Because if you memorize the way it is being solved, not necessarily the same unit, the same numbers, the same even, but the way how it is being solved, memorize it. I mean, the strategy, the technique, how to solve that way. If that kind of problem will repeat again and will come out again, the same story, then you can solve now because you solve that already very well in a multiple manner like that. So that's what also I did when I was in, before I take my board examination. I study how it is being solved. Okay, and then for example, 1, 2, 3, 4, 5, 6, 10 types of technique how it is being solved. And then if it come to the examination, then I can really solve that because I solved that in that way, like that, and the data only is being changed, the numbers, the units, but the way how it is being solved, I memorize it already because I told you before I'm not good in mathematics. Okay, no need for me to analyze very well because my mathematical ability is not very high. Okay, average only. I don't like mathematics. That's why. Okay, so that's why I memorized how it is being solved and I understand how it is being done like that. Okay, but the only disadvantage in my time before, if I will be presented a question that it is not being presented pa in my mind. So, mahirapan talaga ako dyan. Okay, because that's the time we'll measure how good you are in mathematical ability. If the question, you never meet that in your entire life, okay, you meet that in the first time, and then you analyze that there. So that's the advantage for the students that have a high mathematical ability or good in math. Okay, that's their advantage really. It could not be denied. Okay, but in my case, I don't have that quality. Okay, that's why. Okay, that's the reason why my general engineering score is not high. Okay, and it pulled the result. Okay, it pulled the result. My highest is chemical engineering, followed by physical and chemical principles, and my general engineering that involves mathematics are the low. And then if you divide the three, the the result will still pass, but if I have a high, this general engineering, maybe it can pull up the average also. Okay, maybe it will go to, ano din lang ako mention, charot! Talaga. Maybe it will become 80 plus. Okay? My average in the board examination. Talaga. Okay? So that's it. Okay, we'll go to the second part. Makakausap ko, gutom na juga ko class. We will be going back to the reaction order and oy, fairness. Ganon. And then, stoichiometric relationship between quantities, and then the graph. Okay. Number 7, hypothetical reactions, rate of appearance and appearance. Ba yan, nakakaloka. Number 8, problem solving, the last. Okay. Application naman ko ng problem solving. Okay? Sa mga knowledge. Okay? Thank you so much, guys, for watching this first segment or first part of this live streaming regarding chemical reaction engineering. Okay, reaction mechanism. Okay, you can comment down below in the comment section, and you can also see you later after my dinner.